Hello students, and welcome to another video. I'm your teacher, Mr. Flynn, and today we're going to be talking about modern atomic theory. So in the previous video, we talked about the Bohr model, and we talked about how electrons exist in rings around the nucleus of an atom. Now, that's not actually how electrons move around an atom. They don't move around in rings. They're actually found in these things called atomic orbitals. All right, so I want you to write down these two definitions here, the quantum mechanical model and the atomic orbital. So the old model was the Bohr model. Actually, there's been several models. Okay, the Bohr was the one we had most recently until we came up with the quantum mechanical model. All right, the previous models, we won't go into depth in this chapter. We might do it later when we talk about the periodic table, but for now, the only two that I really need you to know are the Bohr models and the quantum mechanical. Okay, the Bohr model still has a place. It's good to it's easy to use to describe atomic emission spectra. But when it comes to actually understanding what it really looks like and what's a more accurate representation, the quantum mechanical model is the one that we use. And it's based on an equation by Dr. Schrodinger. All right? And I want you to imagine that electrons are found in areas of the highest probability, all right? And we call that an atomic orbital. So if we think about a hummingbird, right, down here below. I remember at my grandma's cabin, there's a little bird feeder they had, or a hummingbird feeder, and it had sugar water in it. And you can go up and you can put your fingertips on the edge of the ring, and they'll land on your hands. And I remember just looking at those wings flapping back and forth very quickly. And once you pinpointed a place on where that wing was found, it already moved. And then you had to measure it again, and that wing would already move. And then it kind of made this gray area, which is where it's kind of the highest probability of finding a wing. Do you think I'm going to find a wing close to its head? Probably not. But if I look in this area, the likelihood of me seeing a wing is much higher. Because once you measure the placement of a wing, it's already moved again. And you measure it again, it moves again. And that's how electrons are. When you're looking at them, they are moving so fast that once you find the location of it, it's already moved to the next place. So the idea is the closest we can get to as finding the location of an electron is based on a general probability of its placement, and we call that an atomic orbital. Okay, and if you look at this atom, we've got a dark blue area and kind of a light blue area. So you can kind of see in this image that an electron is most likely to be found in that blue area. Okay, and we would call that an atomic orbital. But this is not really accurate. This is a very simplified version. Okay, of where an electron could be found. But we know that it's going to be found more here than out here. Right? Same with the hummingbird's wings. Now, this image can be very daunting to look at for the first time. It can be very confusing. But as you get to know and understand this model, it will make more and more sense. So you will have to come back to this picture multiple times, and it will start to make sense. And all the pieces fit together nicely, but understanding what each piece represents can be challenging. All right? Just like the Bohr model, we have energy levels, but we call them shells. So we have energy shell 1, 2, 3, and 4. And the farther you go out, the higher the energy. So the lowest energy levels are down here. Okay? Now, the number of electrons you can fit in each of these shells is 2, 8, 18, and 32. All right? And I'll explain to you how they organize themselves in subshells in a moment. Okay, so the idea is that the highest energy level is out here, and electrons want to be at the lowest energy level possible, so they want to be down in level 1. Okay, but if it's filled, you have to go to the next level, and if it's filled here, you got to go to the next level. If it's filled, you got to go to the next level. It's kind of like there's only so many rooms in the inn, and if you have 3 electrons, 2 of them will be in the first level, and then 1 of them will have to live in energy level 2. Okay, so there's only a certain number of slots for an electron to sit, so it's going to work its way out from there. Okay. Now, there's 2, 8, 18, and 32. Those are the number of electrons you can fit in each of these shells. But inside of these energy shells, we have subshells. And these electrons will arrange themselves in an order of these subshells. And if you notice, we have S, P, D, and F. Those are the different ones. And there's no F subshell in level 1 because there's not enough space for it. All right, and there's no D in level 2 or 1 because there's no space for it. So the idea here is that as you work your way up, there's more complexity. The farther you go out, the more complex it gets. All right, most of the things we will be working with in class and examples will be in the first and second energy levels. Rarely will we get into the D and F blocks way out here in the distance. There's more energy out here that's required to keep them, and it's more complex. So it's more simpler when you work with atoms that are smaller in number, between 2 to maybe 10 or so. Okay? All right. Let's flip the page and let's describe what these orbitals look like. Okay, remember how I said there's 4 of them. There's S, P, D, and F. And there is a ranking to them. Just like I have here, I'll come back to this page. Just as if there's an energy level of 1, 2, 3, 4, the farther the energy level, the more energy it takes to stay there. Okay, there is a pecking order of the shells as well. All right, the S orbital will always be filled before the P, and the P will always be filled before the D, and the D will always be filled before the F. So there is a pecking order within a subshell of S, P, D, and F, and it's beautifully organized on our periodic table. And as we work through it, it will make more sense in the next section. Okay, this is just more of an overview discussion, and in the next video, we're actually going to talk about how we organize those electrons in these shells, in these subshells, and it will start to come together and how the periodic table is built. Okay, now the 2 shells I told you we're going to care about the most is S and P. We're not going to really talk about D and F, so I'm not going to talk about them. So the S orbital can hold 2 electrons. Remember my image here? It can hold 2, right, in this first shell. Now, if we look at the subshell, it can hold 2 in here. So there, you can think of it this way. I don't know, do we talk about it in this chapter? It will be talked about later. I won't talk about it. I'll keep it simple. We can fit 2 electrons in this S orbital. All right? In the P orbital, we can fit 6. All right, but there's 3 different varieties here. We have a dumbbell that goes on the X, the Z, and the Y axes. And if you think about it, this is 3-dimensional space. All right, and these are dumbbell shapes. These are not 2 separate orbitals. They are connected to each other. So there's 3 of them. And if you can imagine, each orbital can hold 2. That means this X orbital dumbbell shape can hold 2, this can hold 2, and this can hold 2. So that's 8. Sorry, that's 6. But with a total, in the second energy shell, we can hold 8. So let's look at this real quick. We can fit basically 2 electrons in each box, right? This is the S shape, and it's an S shape. And then the next one, we have the energy level 2. It also has an S, and we can put 2 electrons in this box. And then the P has 3 dumbbell shapes, and it can put 2 in each box, so we can have 8. You see that? And if you work your way out to these farther ones, you can put 2 in each of these, and you can get 18 and 32. So the idea here is there is a pecking order to the energy shells from 1, 2, 3, and 4, but there's also a pecking order inside of them. So they're going to fill the S before the P, and then the P before the D, and the D before the F. And those D and Fs only exist in the outer shells. And we won't work with those a lot in this class because it's an introductory course. Okay? But for right now, I just want you to know there's a pecking order. You want to fill the lowest energy level and the S first. And then if that's full, you go to the 2S. You fill this one, and then you go to the next, and you fill the next. So we're talking about how electrons arrange themselves outside of this periodic table. And that's what the whole next chapter is about. It's on electron configurations, or how electrons arrange themselves around an atom. Okay? So let's imagine it in a 3D model. Okay? If we look closely, I'm going to zoom in here. It's kind of hard to see it. But there is a inner layer, there's an inner one inside here. We call that the 1s. So that will have 2 electrons. But we actually have, like, just say 10 electrons available. This is magnesium. We'll do this. Magnesium has 12 electrons. How are we going to order those electrons, and how are we going to find their location around the shell? So we have this first number is referring to the energy shell, or the energy level. Okay, so we have 1, 2, and 3. And you remember there's a pecking order to how they fill. But only 1s, energy level 1, only has 1 subshell, and that's S. So it's going to have 2 electrons in this first one. And then we're going to go to the second energy level. And the second energy level has an S and P orbitals. So we'll put 2 electrons in the S, the 2s, which is a little bit bigger than the first energy level. It's going out further. It's this shape for this 2s. And you can put 2 electrons in there. And then this 2p, right, we're talking about the second energy level. And we're talking about the P is the subshell. Okay. And then because we know that there's 3 sets of dumbbells, we have 1, 2, and 3, and we can put 2 electrons in each of those, so that's 6. All right? If you're feeling a little lost, it's okay. We're going to spend a whole section talking about this in the next video. I'm just giving you an introduction. And then lastly, if we have more electrons that we need to place, we're going to put them out further in this 3s shape. And if we had more electrons still, we can make more p shells to fill in. Okay? So let's just recap. If I have this shell model, the big thing I want you to take away from this video is that electrons are going to want to fill at the lowest energy levels, 1, 2, 3, and 4. Inside each one of these energy shells, we have subshells. And there's a pecking order within them. So you got to fill the S before the P before the D. So you work your way across, and you have to fill them in as you go. And what do these shapes look like? Well, S is a sphere, P are dumbbells, D and F are complex. But P looks like dumbbells, and there's 3 sets of dumbbells, that one on the X, the Y, and the Z axes. All right? All right? And if you look down here, here's another image that describes the same phenomena. But it gives it to you in the periodic table view. So if you look here, we actually, I'll show it to you later. I'll just show you this picture. As you work your way across, as you have more and more complex more arrangements, and there's more electrons available, you're going to fill your periodic table this way. You're going to start with the S block, work to the P, the D, and the F. Okay? And I will explain this more in the next video, but the idea is as you fill those electrons around in that electron cloud, they're going to arrange themselves in this way. All right, and you can come back to this image, and it will make more sense later. I think this will be a better image to show later, but take some time to appreciate it, to understand that as you work your way down the table, there's going to be more electrons, and this is how they're going to fill, and these subshells, P, D, and F, and S, are the shapes that these blocks look like. Okay? Thanks for watching. I will make another video talking about how electrons are arranged. Okay, we briefly touched about it. The next video I'm going to talk about it. This video was just talking about their shapes and kind of a basic overview. Okay? Thanks again for watching. Until next time.